All right, boys and girls, let's take a look at problem number one. Number one says a laser emits light with a frequency of 5.22 times 10 to the 14th seconds to the minus 1. Right, frequency is the Greek letter nu. So we'll say nu is equal to 5.22 times 10 to the 14th seconds to the minus 1. Right. Now just real quickly, seconds to the minus 1 is also a per second, or sometimes we call it a hertz, Hz for hertz. Right. And we want to know what is the wavelength of the light in nanometers. Right. Now, the way we go about doing this is to utilize this equation. The speed of light is always the wavelength of the light times its frequency. I want to know wavelength. So I'm going to take this equation, divide both sides by nu. You're going to cancel on this side, so I'll get lambda, the wavelength, is equal to c divided by nu. And that's the equation I'm going to plug into. All right, so let's sort of back up here a little bit and do it this way. Lambda is equal to c divided by nu. Lambda, the wavelength, is equal to the speed of light, which is 3.00 times 10 to the 8th meters per second, divided by the frequency, which is this number up here, 5.22 times 10 to the 14th per second. All right, seconds to the minus 1 is the same as a per second, which is something to keep your eyeballs on here, because you want to make sure your units are working out properly. If I have a meter per second on top and a per second on bottom, the per seconds cancel, and I'm left solely with units of meters. Right? Now when I plug these two numbers into my calculator, I get a lambda, or wavelength, of 5.7 times 10 to the minus 7 meters. Now, if you left your answer just like that, you would have missed the important part of this problem, or one of the important parts, and that is to express wavelength in nanometers, which is typically the case when you're dealing with light, to express the wavelength in nanometers. So how do we get from meters to nanometers? Now, we have to consider this metric conversion ladder, this prefix ladder. I want to go from meters, which is the base unit, down to nano, which is down here. Now, if I count the number of jumps, we're going to see that it's 9 jumps to get from base unit down to nano, which means I'm going to be changing this, right, by 9. Right, so I'm either going to add 9 or subtract 9 from that negative 7. Which one do I do? Well, if we go back to here, if we're going down this list, we want to move the decimal point to the right. But what does that mean in terms of changing numbers in scientific notation? What it means is that we want to add to the exponent. So when numbers are in scientific notation, we add to the exponent. All right. And obviously, if we were going up the metric prefix ladder, here it says move the decimal point to the left. But what if we're dealing with numbers in scientific notation? Then we would ignore that, and we would simply say to subtract from the exponent. Anyway, so now we're going to add. We're going to add 9 to the negative 7 to get our answer. It'll be lambda equal to 5.7 times 10 to the what? Add 9 to negative 7 and you get 2. All right. Now I could express this out of scientific notation. Times 10 squared means times 100, and when you multiply by 100, Move the decimal point 2 places that way to the right. So the answer is either lambda equals 5.7 times 10 squared nanometers or 570 nanometers.